So let me ask you some questions first. What was the last time you checked your electricity bill? Do you understand the activities you do at your home? How does it affect your energy consumption and your electricity bill? Hold on, answer my question after the presentation. We found some comments from a Chinese internet user on Kenya discussion talking about the electricity bill he received in January and February, which has a big difference with average monthly cost he had. And a lot of comments gave the same complaints. And similarly, the first interview we had in the field trip was with Edgar, who had a typical middle-class family living with his wife and two young children in Querétaro, Mexico. And here's their family's picture and also the Querétaro's location. In the beginning of each month, utility company will send out the electricity bill to his house. He seldom checked the details of the bill until the one received in September was doubled compared to previous months. When he was showing us the bill, he was so furious and confused at the same time. There must have something wrong with the price system, he said. But does it mean the bill has a problem? No, Edgar does not know how the system works and how much he consumed. It is rare for us to check the electricity bill until the bill is too high to be accepted. If the individual cannot fully understand the electricity bill, it may not hurt but pay a little bit or a lot of money. But if the company of the country cannot have a good plan of energy supply, the consequence would be very inconceivable. Therefore, good energy demand estimation is of great importance. If the power grid does not know the demand for electricity, it may be more power plants leading to excessive investment. On the other hand, it may not build enough plants and results in power outage or importing high electricity. The well-managed demand side provides significant reliability and economic benefits. So how can we solve the problem for the estimation?
To do the estimation, there are three traditional methods as shown on the table. The first is electricity bill, along people with other economic, social, and even environmental data. The second is interview, where we will ask them how they consume electricity and applying usage. The third one is real-time monitoring. So we monitor the electricity consumption in real time. In field trip, we test all these three traditional methods. This is the electricity bill we collect. So they contain electricity consumptions, electricity costs, and even subsidies. We also conduct interview in 32 households in the city, asking them about their socioeconomic status, appliance usage, and their willingness to buy a new appliance. It covers different income level, type of house, number of residents, and a lot of other aspects, and we are quite welcomed by them, as you can see in the pictures. As for the monitors, we first install a monitor as their electricity meters to monitor the whole household consumptions. And for some specific appliance, we will use special equipment like this to monitor the certain behavior of some specific appliance. So when people use electricity bill to build a model, we always need some assumptions. So one common assumption is like the higher income will lead to a higher electricity consumptions. However, it is not always the case. From the survey finds that it's kind of like a U curve. When income per capita increased after certain thresholds, this increase will lead a decrease in the electricity consumptions. This indicates that the electricity bill alone cannot provide us enough information to build any estimations. When we look deeper into the survey, we can find that families with different income level will spend different proportion of their income and energies. The higher income communities will spend a lower proportion of their money on energy. And even in the energy consumption, we can find their expenditure on electricity will be different. The lower income communities will spend a little bit more portion of their energy expenditure on electricity. So this explains why we have this relationship with income and electricity consumptions. But whether it's good enough for us to provide an estimation on the total energy consumptions, we make an attempt. As you can see from the curve, this is based on what we gain from their household, how they use the appliance, when they use the appliance, and how the appliance consumes the electricity. We find that Wi-Fi is open all the time. The iPad and iPhone was charged overnight. Cooking happened this morning. And the lighting consumes a lot of energy in the evening. This data is pretty good. It's similar to the average value from the real-time monitoring we get. As shown in the graph, it is all average values. They have similar trends, similar peaks, and through all the days. However, to do the planning on electricity, we need to meet both maximum and both minimal demand. So the center tells us the maximum demand is such high, so leaving a huge difference between the average and the maximum. This indicates that the survey is not good enough for us to do good estimations. The real-time monitoring, of course, this is really good at recording, but it may not good at estimating the future consumptions. We find that although it's a little better than the survey data, it still has 15% difference with the real consumption, which we validate with the electricity bill. So how can we build a better estimations?
So we can take advantage of the benefits of these three methods. First, surveys. Their main advantage is that they can be designed to get the data that we need, like electricity use types of household appliances. They can be used to get data about all fuels and provide high-quality results. However, surveys are expensive, time-consuming, and they require extensive validation. Then we have the administrative data. The best example of these methods are probably the use of the energy consumption data provided by electric companies. This is what we call electricity bills. Administrative data is cost-effective and in theory eliminates sample errors. Also, they are less time-consuming and provide access to a lot of records. The disadvantage is that energy companies may not be legally allowed to share data that contains personal identifiers. In some countries like Mexico, there are legal barriers to use these methods and some limitations in the type of data that can be collected. Finally, we have in situ measurements or sensors. This approach provides very detailed data that can be used in modeling and other work. Additionally, with extra computer analysis, this method can be used to get a better knowledge about the real electricity consumption by end users. Nevertheless, this approach is expensive, restricted by technical limitations, and requires a more intrusive intervention. No matter what method is used, the selection of households for the sample must follow a structured sample design to have a representative sample of the households. In our field trip, we couldn't interview enough households that can provide us a representative sample. We need more resources and the approval from a utility company or from the government to get access to the type and amount of household required. For example, the sample normally starts with a minimum of 0.1% of the population. In a city like Querétaro, with more than 300,000 houses, we will need at least 3 houses to survey. However, we combined the information collected from the 3 methods, and we built a preliminary model to explain the behavior of the electricity consumption. Modeling. As we have seen, determining energy consumption is complex because private households often cannot provide the needed data, or the information needed is not available, or it is expensive to obtain. This is the perfect starting point to think about using modeling to make not available information available. Applying models can help to reduce the frequency and the amount of information required to characterize energy consumption. This saves resources and time. In this way, we built a preliminary model that shows the relationship between the monthly average electricity consumption per household with some variables. We found that this model had a 59% of response variation that can be explained by these variables. A change in the number of light bulbs in a household is associated with an increase of 4.2% in the electricity consumption. A change in the area construction in the household is associated with an increase of 0.24% in the electricity consumption. And a change in the number of days that the household is occupied, it is associated with an increase of 0.29% in the energy consumption. Although the response variation is low, this model represents a big step in the characterization of the electricity demand. We are still working in this project. Now, we are collecting and analyzing information from nationwide databases. There is also some future work that can be done to improve our results. First, increasing the sample size and the timeline. Second, to use the sensor to disaggregate the electricity demand. And third, to obtain the support from an electricity utility in Mexico of the government to have access to a representative sample. In addition to that, we believe that by combining these three methods, that the methods that we use to collect data, and with extra information, we can build an accurate energy consumption model, a model that can help electric utilities, investors, and government to characterize energy demand. Companies need to understand that energy consumption, and good data is imperative to do so. We believe that our approach is an important first step in using better resources and look forward to continuing our research. Finally, with our results, we can help people like Edgar to understand their electricity demand pattern. Now that we could measure his energy demand, we can help him to improve it.